All right. Hey, everybody, welcome. I'm so excited to be back at RubyHack. I spoke my very first conference talk was at RubyHack in the inaugural season of RubyHack. Good to be back. I grew up here. I grew up here locally. I work here locally. My lights disappeared locally. Womp womp. Somebody was me. Anyways, my name's Nelson. I work at this company called MX. We're a sponsor. Do we got any MX engineers here? Can you say hello? I started my Ruby and engineering career there. I tried my hand at the startup lotto. So I left, did the startup thing for a couple tries, and then I came back. Like, the engineering culture was so great there that as soon as I decided I need something a little bit more stable, but also I would really like to learn some more and kind of reinvest in myself and my engineering potential, MX was the first place I wanted to look. So we are hiring like mad, so if you're interested, we are literally waiting to hire you around the corner. So yeah, I am excited to talk about this, but first to start off, especially when you have a technical concept like lifecycle events, that might mean something different from me than it is to you. So I really like to start on shared definitions of what that means. So a lifecycle event in my context that I want to talk to you today is, what do we do within our application when we create a record, when we update a record, when we delete a record? These are very common things that happen a lot in our code, and those things could either be good or they could not be so good. And I want to talk about the experience that I've had. I have been doing software for about 8 years, so I guess that's like a medium rare length in this industry. Like, it's I've been around enough to get bit, and I've also been around to learn this is maybe a better pattern for how to do this, and that's what I wanted to share. And since the theme of the conference is leveling up, I thought, especially since a lot of the people who come and work in Ruby came for Rails, this would be a great way for me to help you share my experience of how to level up. So lifecycle events is our topic. And to introduce this, I thought if this abstract explanation wasn't enough, maybe I would start with a little visual here of what I mean with lifecycle events. And it's got to be on theme. I'm going to start over because the sound was off. So, dealing with lifecycle events can either spark joy, or if you've been around and worked and been bit by them in the past, you can know that they can definitely not. They can clutter your life with darkness. So I'm going to go through a couple of tools and design patterns for you that I hope will help you better craft your responsibilities in your business. I already chatted on that a little bit. Actually, a little bit more here. So what's really interesting about lifecycle events and even data in general, because that's really what we're talking about here. So we're manipulating the data that we're storing in our applications. What's wild is that in our industry, there are so many businesses out there that either have no vowels in their name, or they end in ly, or these consumer-grade applications that have a massive scale. A lot of the times, they're giving their tools away for free in exchange for data. So protecting this data, like, they're saying what they really value. I mean, some of the world's most valuable corporations now, they don't really charge for anything per se. They just really want that data, and that their asset is that data. And so if you've ever had a bug come across your desk where it's been associated with data gone wrong, you know how terrifying that can be. So I wanted to dive into this because this is one of the more crucial things to get right for not only your own sanity, but for your users and for your coworkers who have to deal with the fallout of a mistake here. It's very critical to get this piece right. So I thought it justified its own talk. So I really like technical talks that have a shared domain, so we can all kind of get on the same page and not be super abstract when I'm talking about lifecycle events. So I thought I would pitch to you my idea of my next startup. I mean, I've done a couple startups that have failed in the past, but this one I'm pretty sure is going to be a hit. And so here's the idea. So I want to first off start off, here's the name. The name's always important. I'm going to call it the blockchain credit. And if you're not inspired enough already, let me give you a little detail. So I want to do like credit scores on the blockchain, man. Like, I feel like this totally needs to happen. Experian leaks all of our data. Like, we just need something new. And of course, because we've got to be a decorative unicorn, there's going to be some machine learning in there, and some AI. This pitch was almost perfect. I think there's one thing I can do to clean it up. You know, just drop the "the." I think it's cleaner. I think it's cleaner. So when users sign up, so now that you've clearly signed on to my startup and seen my vision, your first task. There's a couple of things that need to happen when a user signs up for our service. We need to create a credit score for them, because that's kind of the whole crux of our application. You can't have a user in this without a credit score to keep track of them. We want to create an alert profile for them so that if you want to receive an email or a push notification from every commercial I've ever seen, apparently that's what a lot of people want with credit, we're going to need to keep track of an object to keep track of your preferences. And then let's send you a welcome email. Welcome to the credit score. I can't even remember what I named my company anymore. Very reasonable expectation for something to happen within a Ruby application, right? So because I'm a visual learner and a visual explainer, I like to kind of diagram this flow for you. So imagine we're going to have an admin who is going to interact with our Rails app, and they're going to create a user. And then next, our Rails app, sure, I can create that. We're going to create an alert profile, create a credit score, and then we're going to send you back that user and send a welcome email to our new user. Like, that, again, very reasonable expectation. But the question is where does this all go in a Rails app? This is pretty easy. My Rails scaffold and creating a company in 15 minutes or less can give me all of this, and I have great RESTful design. But what about all of this stuff? Where does this go? I don't remember that in Rails tutorial. And that's where it brings us to our first tool. And I made this short film here to explain my exact learning progress with active support callbacks, and I'd like to play it for you now.
Hello.
This represents my mentor. When you first see callbacks, your first instinct is to use them everywhere. Which, on the one hand, how powerful is that? That you could literally build an MVP of a product with just using this one tool. But if you've been around enough and been bit enough, this will be your face when you come and this is your first product. And this is why a lot of times Rails gets the baggage that it does, because we use tools in a way that's less than helpful. So I wanted to talk a lot about this. The biggest portion of my talk is talking about callbacks, because I feel like, with Lifecycle events, that is the purpose of this tool. If you're unfamiliar with callbacks, this is how they will look. You will have a user that inherits from your application record, and there's this really cool DSL where you can say, after I create something, I want to do these things. I'm going to create an alert profile, I want to send that welcome email, I want to create that credit score. And it's so incredibly fast, you're done with your ticket, you've proven your value, we're on that way to that Deca unicorn valuation. So let's dive in a little bit more about how these callbacks work. So when callbacks get run, whether you're calling save or you're saying, hey, is this thing valid? Active support callbacks is going to look to see if you've defined any before validation callbacks. What's funny is we were talking about this last night at the bar. I have never used one of these. I don't really have a good example for why you'd use it before validation. Maybe some of you do, but the API is there if you want it. Before you check to see if you're valid, maybe this was my best idea. I don't know. But it will run that function. So you can define a private method called notify Slack of a signup attempt, and at that state, it will run it. When you actually call validate on it, so you can either literally call user.valid, or as part of the callback cycle, if you call save, the first thing it's going to do under the hood is it's going to call valid. So if we have a user and we have a requirement that we need to have an email on this user, we are going to check to see if that email is present. And if it's not, there's this really cool API where it's going to say this user is invalid. It's not going to throw up an error, but it's going to give you this really nice API to present to your user and to your APIs that there's a problem with this user, and the problem was there was no email address. Like that, the power that comes from this coupling is super powerful. And then after it calls that valid check, if it was valid, it will continue on, and it will look for any after validation hooks. Again, I have no idea. I haven't really used a ton of after validation hooks, but it will check for it here. After the validation process, it will start to check any before save or before creates. So before you're going to save, which could be either updating or creating, it's going to look for any of those hooks, and these ones are super popular. I really like these for like setting auditing. So if we needed to keep track of which user was creating this user or modifying this transaction, like these before create and before save callbacks are really powerful. After that, it's going to look for after create, after save, after commit. I kind of ran out of examples here, so do a thing. I think you get the idea. So this again, API is super powerful, and like Buddy the Elf, it is very easy to get carried away with what you can do there. It's very tempting to just throw all of your business logic into a callback, but over time, it gets nasty, and I'll dive more into that in a bit. So the pros of callbacks, as I've said before, it's super easy. Anyone can quickly read that documentation and be off to the races and implement a lot of stuff and build some really cool stuff. Like, I don't want to discount that it's actually doing the job. It's just as you grow, it might not be what you're expecting. It pairs really well with validations. They're easily testable, and a huge pro is they run at every database operation. So if you create a user in a console, if you create a user in a controller, whatever input you're going through that uses active record, it's going to run all of these. And you're probably expecting the first con of active record callbacks is they run it every time. So if you ever needed to sidestep that process, you're going to be looking at a lot of conditional code, and your already complex callbacks are now getting that much worse. There are a lot of potential for race conditions, especially if you've architected them like we have in our example here, where you're expecting this thing to be inherently present, but it's not because it hasn't been created yet, or maybe there was another error somewhere down the line. I already talked about this complex conditional logic that comes in place, and here's a really bad joke about illustrating how race conditions work. They have a lot of potential for this if you're using them incorrectly. So here it is again, and here's my first pro tip. So if you're working with callbacks, they should only modify the model that they are defined on. Okay? I'm going to repeat it because I think this is important. They should only model. No, you're good, Steve. They should only modify the model that they're defined on. And to illustrate that, here's a little comparative view. So here's how your database views your models. And here's how our application would view that model with that architecture. So you thought they were separate, but in all reality, there's this illustrious God user object with a goiter of an alert profile and credit score just hanging out. Like, this is your database. You might think you have this accomplishment of separating your records, but in all reality, from the business side, this is all the same thing at this point. So if you are modifying an alert profile or a credit score from a user callback, like trying to visualize that flow of logic, super hard. It's not linear. You don't have, like if you have a bug with an alert profile, you're going to open up the user record. That's not intuitive. So do not modify another object in a callback. Only the model that it's defined on, right? So your model responsibilities are not respected. And we talked about this yesterday in Kelly's presentation. What if we don't actually want to send that welcome email all the time? What if our credit score creation process needs to vary? And what if we need a new API? What if we need to change from version 2 on, we're going to change how this works, right? So callbacks should only modify the model that they are defined on. And if I'm not getting the point across, allow me to illustrate this in the most millennial way I know how, through an inspirational Instagram post. I mean, there's a lot of people who say just don't use callbacks at all, but I think that's a little excessive. Just don't modify any other associated objects. So in this case, we have an alert. We're creating an alert profile. We're creating a credit score. This breaks my rule. No zoom for you. It's not. That design pattern will hurt you over time. So that raises the question, well, does that mean I can't use any associations anywhere in my callbacks? So here we're checking to see if our credit score is good before we update a status. This is read only, and I say that's all right, all right, all right. Again, I would only use those associations if you have to, because again, you do want to keep your models as loosely coupled as you can, but in real life, that's just not always an option. So, and if I haven't beat this horse to death entirely, here's another example. So later, elsewhere in our cool application, we have a transaction. So this is like a financial transaction, right? And we see this cool callback that again makes complete logical sense for what our application is trying to do. Before we save, we want to update this user's credit score. Again, very, very reasonable expectation. But then when we dive into this thing, it looks a lot like this. It's like this beautifully named like private method that's like a landmine waiting for you. And if you're wondering why some people here have they're suffering from cardiac arrest right now, and they're, speaking with Michael, the arch Linux angel of callback hell, let me explain why this is so bad. All within this transaction. Remember, this is going to happen every time we update or create a transaction. We're going to check, hey, there's this concept of debt that who knows where that came from. Was it paid on time? So now we're dealing with time, and time is hell, as we all know. And then we're going to actually modify the credit score. We have this concept of, is it our credit ratio too high? So again, another concept that's tightly coupled to this transaction, that these things are all just the same thing. I don't know why we've separated them into separate files. They might as well just be in one giant file and say, hey, this is my cool app. Thanks for staying. We have, of course, some really cool return early clauses for if we have a test user, if we have a demo user, if our CEO's nephew has really crappy credit, and they're like, you know what, let's just, because we're a blockchain company, I need you to look out for him. And then we have these amazing, we're going to report to external services, it looks like. We're going to actually share our credit scores with, and this is going to happen after every transaction that assumes that all of these credit bureaus are online. Oh my gosh. Ugh. Callbacks should only modify the model that they are defined on. Can we all chant that together real quick? Callbacks should only modify the model they are defined on. All right, I think I've made my point at this point. So with our implementation, even though it gets the job done, we've got a bug that came in. My favorite type of bug that start with the word sometimes, because who knows where to start there? Sometimes our new users aren't getting their emails, right? So I think the first question is why. So I would look into that bug and say, all right, let's find that user, pull them up in a console and see what we can figure out. So we're going to say, hey, your alert profile, why didn't you get the email? Oh, it's not there. You dive further and you see that someone added a model validation on alert profile that only happens some of the time. You wouldn't know to look there because they're in separate files, right? So what should have happened to our user in that scenario? It doesn't have an alert profile. Should have it been created at all? Should it have been allowed to exist? And again, we're going to see bugs when we try to send that user email in the future. So we have this assumption that all of our users have an alert profile, but it's clearly not always happening. So how do we ensure that all three of our objects are created? We fix my code smell and our bug at once. And that's our next tool here. Let's throw back to the golden age of video games. Active record transactions. So again, if you have that requirement where you're expecting all of these associated models to come into play, to be created at once, these transactions is the perfect tool for that because it gives you an API where it's either whatever operations we're going to make to this database, it's either all or it's nothing. I either want to create all of these or I want to create nothing. So this is how this would be implemented. So at first you have your user, your alert profile, your credit score. All of these are wrapped into this transaction so that if anything goes wrong, we're going to roll this back and nothing actually gets done. So all or nothing. And the way that it rolls back is it looks for runtime errors. So if you add this bang method on the create, rather than giving you that really handy validation API, it will raise a runtime error. And when that does, everything that's happened before that gets rolled back. So we don't actually get the user created, and we can tell our interface that, hold up, that user wasn't actually created, so we can respond as needed, right? So that solves our bug. But the question is where does this cool transaction actually fit in Rails? Does it fit in the model? The controller? See, there's this really popular blog post that you shouldn't have a fat controller, you should have a fat model. And then the world was like, no, fat's bad. So we don't want all this responsibility in one place because it just gets weird. Unlike Weird Al Yankovic, who's an American hero. So where does it all live? Where does it go? We could easily throw it into a callback, but that breaks my rule, right? No soup for you. We could put a new controller in here. It doesn't look that bad because it's another, 4 or 5 lines, like not that painful. But when we put our callback from hell in here on transactions, we see that this controller's responsibility is expanding tremendously. Can you imagine like doing a Rails controller test for this? Like, anyways, there's got to be a better place. So please no, not on the model, not on the controller. Where do I put that? Service objects. Service objects, I remember when I first kind of saw this, it was weird. And then I was blown away, and I had a Buddy the Elf experience again, where I think any time we learn a new tool, we just kind of put everything into it. A service object, according to my favorite Fancy Nancy novel, is just a fancy name for a vanilla Ruby object. Because you have your Ruby object, and then you have your service objects. I mean, everything in Ruby is an object, so a service object is just an object that has a very defined purpose, right? So here's an example of one, and when I say service object, I'm implying that we're going to instantiate something, we're going to use state. We had a great talk about functional programming, and this kind of gives you an idea of how that might look. I actually don't love this implementation, but it kind of gets the idea across. So the first thing you'll notice, this class, this user service, it has no inheritance. And again, if you came to Ruby because of the Rails, but you stayed for the Ruby, this might be different for you. There's no Rails generator that's going to give you a cool service. Like this is it's up to you. Like you get to ink how all of this code flow gets to work, which I find incredibly liberating, especially as your business logic is completely specific to you, and also why it doesn't belong in a model, because it's not tied to that. Anyways, so how this will work is we're going to send our params that we'd have gotten from a controller. We're going to instantiate a new service object, and that will set our state by saying these are our params we need for our user, or for our alert, for our credit score, and then it will go off and create those objects. So this is a dedicated object that does exactly what we need to. We can call this flow whenever we need it. But not all of us love object-oriented programming, especially for data transformation like this. So you don't have to use a service object. You can use something a little more functional, a procedure, and that could look something like this. And here there's no adder readers that you're referring to for your state. You're just storing them as local variables and passing them around. And that's why you have the ultimate Winnie the Pooh of the procedure. I was too lazy to figure out how to separate the monocle and the mustache, so. I think my conclusion is I don't really have a huge horse in the race. Like whatever your team prefers, like if OO is natural to them, then totally fine. The good news is if you're breaking all of this logic into a dedicated place, testing it and iterating upon it is super easy because it's got its dedicated home. You know where to reach for to test it. So throw it into a service object or a procedure, and you will your life will be happy. I promise you. Also versioning. I mean, is versioning is that a monopoly that a controller owns by itself? No. I mean, you can throw any service into a version module, and then if you needed to change this at any point, like if you needed to change your sign-up flow, you usually could without breaking former implementation. Doing that in callbacks is near impossible. So these service objects are incredibly powerful. So where do they live in Rails? I've seen people put them in the model directory. I don't love that because when I hear model, I think of active record models that have a data source to it. But again, it's up to your team. I personally prefer the services directory, creating a new directory in your app structure where you can keep all of your services. I've also seen it in the lib directory, so you know that it's not part of the Rails app, but it's your own logic. Again, since you are penning where this all goes, it's kind of up to you and your team to know where are we going to put all this logic. So the pros of service objects: single responsibility for everyone, right? So everything has its job, and it's easily contained, and you can plug and play them wherever you will. They're a lot easier to test. They're super easy to version. When you have complex conditionals that come into place, at least they're all in one place, and you know that if you're going to be changing something here, it'll only change this flow. It's like the age-old QA engineer's tale of 99 bottles of beer on the wall, take one down, pass it around, 376 bottles of beer on the wall. Service objects help contain the changing of one thing and then seeing inexplicable changes somewhere else, kind of like we talked about earlier with those modifying callbacks in a different object. It's super easy to sidestep the entire service pipeline. So if you did need to upload a CSV of a bunch of users, not send an email out to them, you can do so by just calling user.create. It doesn't need to necessarily use this pipeline, although I would recommend you adding a different pipeline, a CSV pipeline perhaps, so that you can have still get your associated models created with it, but you don't do so with having to break the functionality of the rest of your app. And the biggest pro of all, it's not tied to every database event. It's also the biggest con. So if you're expecting that every user have those objects, if someone were to subvert that without using one of your service pipelines, then you're going to run into that same nil class bug, right? It's not vanilla Rails, so it might take a little bit of a learning curve. And the biggest con is you have to figure out how an error handling pattern for your services. When dealing with Rails and active model, you have the validation errors that are amazing. I've seen people actually include that same module into a service object so they can have that same interface. But it's something that you'll have to implement on your own and decide on with your team. So what does our Rails app look like with this new architecture? Our model is as skinny as it can't legally allowed to be. Our controller is super simple. It's going to take the params that we get from a create request, throw it to our user service, and render the show from the returned user object. And our service is, as we already talked about, probably hanging out in the services directory somewhere. Our data and our application have distinct boundaries. Boundary issues is a big thing, but now that we've kind of clearly tamed Rails and to know how to work with each other, everything is awesome. But all of this is making an assumption off of an architecture, and that's that all of this is contained in one app. And that's not always the case with everything. And so that brings us to our next subject. I think some of you might know where I'm going with this.
Hey, hi there, little fella. Come out here. Do you know a way out of here?
Microservices, distributed computing, it is a natural part of life. Depending on the organization, you can go a long ways before you have to break it up. Other times you're coming into a new organization and this is just the way the organization is architected. And so even though you might be a pure monolith, kind of an engineer, that's not always a convenience that's available to you. So the question is outside of a single Rails app, how do we handle these lifecycle events that kind of drive our data model, right? So one option is we could write a service that when we create our user, it will go out and make these HTTP requests or RPC calls or whatever to these various apps within our environment. And while that could work, the question is do you really need all of those services to be healthy to create a user? I mean, if they're not your app, should you care? And that's where publish subscribe comes in. And publish subscribe, if you're new to this world, again, I'm a visual learner, so I like this idea of, hey, when I publish something, I'm just putting it out to the world, and I'm letting the world do what they will with it. So it's kind of like this. You create a user, the world's going to react either positively or negatively. And then the only responsibility that you have is sending the message out and letting the world do what it will with that information. It's not your job to be responsible for your marketing app, your CRM. All you need to know is, hey, we have a user now. It's super easy. You could throw in a callback here where after we are making our modifications to our record, we're going to publish this out. So I've seen this extracted several times in different companies that I've been at where at every Lifecycle event, they'll have some really cool interface to say, hey, this is how, if you're interested in user creates, this is the key that you need to subscribe to. And so I've had a lot of success working with RabbitMQ with this type of flow. I've always wanted to use Kafka, but again, when things are in place, it's kind of hard to move something so critical. So I haven't actually played around with Kafka, but there's a lot of really cool advantages to Kafka over RabbitMQ that I highly recommend you look at before you implement one of these. But the ideas are similar for the code flow. It will look like this. We have our credit app, and it has a JSON representation of that new user we've created. It'll publish it to our messaging queue, to RabbitMQ, and it does something cool. It'll take that message, and for every queue that subscribes to that event, it will have its own dedicated queue to process those. So that if and when CRMs, and they never go down, but entirely hypothetical here, if they do go down, should your alerting application be affected? Should your business intelligence application be affected? No, they shouldn't. And what's cool is as soon as that CRM comes back up, all of the messages that it missed out on while it was down, it gets to then process and continue on like usual. So this makes for a very resilient system when working with lifecycle events. It's really cool. I really like it. The pros, you're not actually dependent. Like something can be down and all you have to do is publish it to that messaging service and you're good to go. You don't need a service object anymore because you're just publishing your state and letting the world do with it what they will. You don't need any gnarly callbacks. It's not even a temptation. Not today, Satan. It is also resilient to downtime. We talked about that already. And everyone minds their own business. They have their responsibility of their app, and that's all they care about. The cons is if and when things get out of sync, either to availability issues, let's say your Rabbit cluster goes down, or there's a bug with an update. When this happens, it can be pretty dangerous. Luckily, these tools have been around for so long, and there's so much investment going in to make these resilient. This isn't. While you will run into it, in an MX, we push it to the absolute limit because we have trillions of transactions in our databases, and we use Rabbit to broadcast our lifecycle events. And so we've run into issues and had to do a lot of fine-tuning, but it's given us this environment where we can have that resiliency, right? You are still susceptible to those race conditions or those orphans that we talked about before because, again, you're not responsible for the alert app anymore. You're just telling the world, hey, I created a user. And if that alert app's not doing its job, then you're open to problems. It also, if you're not careful, it can enable this phenomenon called the distributed monolith, where you think you are being really cool by separating out these apps, but since they're so dependent upon these lifecycle events, you're actually just creating a big monolithic app that's just spread out. So you're getting all of the cons of the distributed monolith without the pros. So you need to be very careful that you are using these messages responsibly. Do not become overly dependent upon them. But they're really nice for, let's say, you need to create a Salesforce record for all of your users, right? So again, not heavily reliant, but upon the state being up to date. But you definitely want to know when those users were created, so you're going to know how to build them. This is very critical functionality. And another huge con, and this, again, I kind of alluded to this in my first point, it is a big single point of failure. So you'll have to make sure you really do your homework to make sure it works well. So in review, callbacks. You could have guessed, do not modify other objects. Use them, but they are meant to help manage the state and the decoration and all of that for that model they're defined on and not for others. They're great for setting for database fields on that. If you have associated models, you can use them in a callback, but only in a read-only manner. For transactions, if you require many records to be created in line, many changes to be made, wrap them in a database transaction, and you can make sure you're going to get all or nothing of that behavior. And please don't put them in callbacks. So for service objects, use services when you're required to do a service-dependent database call and a lifecycle event. Because this way, it's easily encapsulated. If you ever need to change behavior, you can version it. It's easily testable. Your business logic should not be tied to database actions. Keeps your model separate. For distributing messages, this is a great way for setting boundaries of responsibilities for apps. They're resilient to downtime, but they're not immune to orphans and erase conditions. So I've kind of gone all over these tools, and I've given you a lot of pros and cons. The more that I've experienced with software is there's never a right way to do anything. There's always here's all of the information that's out there about what I need to build. How can I take what tools I know that are out there and weigh those pros and cons with what I need to get done? So none of these solutions will be bulletproof, and you need to know when they will hurt you rather than help you. And that's why I've tried to be as open as I can about some of the deficiencies of some of these tools. But yeah, that's it. So thank you very much.